Good evening to all of you. Hello, I am Saikat Giri, your chemistry educator. Today we are going to start one of the most important topic of atomic structure, that is named as hydrogen spectrum. Generally, from this topic we get one mathematical question. Sometimes theoretical question also comes in JEE mains and in advanced exam as well. Sometimes few questions in NEET also we can see. So let's start hydrogen spectrum. So today's topic of discussion is hydrogen spectrum. First question comes to our mind. What is spectrum? Spectrum is actually considered as the radiations of different lines which are arranged with respect to their wavelength, or you can say frequency. We know wavelength and frequency both works in opposite direction. So with respect to different type of radiations, wavelength, we arrange spectrum. Now what do you mean by hydrogen spectrum? Actually, we can differentiate spectrum in many ways. It may be continuous spectrum, discontinuous spectrum, it may be band spectrum, it may be line spectrum. Regarding spectrum, we can say one thing. Spectrums are the fingerprint of atoms. As we know, for every human being, there is a separate fingerprint. Each and every person's fingerprint is separate. Or you can say, for any atom, this spectrum is actually the Aadhaar card of an atom. So to understand an atom, we can use this concept. Clear? So, what is hydrogen spectrum? How can I define hydrogen spectrum? Let us consider what we have done. We have taken an electric discharge tube and here light is passed. When we pass the light, we find out some discontinuous spectrum over here. These spectrum can produce separate spectral lines. These spectral lines are named as spectrum. Now see, how many types of hydrogen spectrums are possible? We are going to differentiate it. First I am taking the line of the spectrums. What is going to be the highest wavelength? What is going to be the lowest wavelength? Why we are getting highest wavelength? Why we are getting lowest wavelength? We are going to discuss on this. So first see, different spectral lines. So first I am taking spectral lines. That is series name. What are the name of the series? First is named as Lyman series. Next one is named as Balmer series. Next one is named as Paschen series. Fourth, named as Brackett series. Fifth one is Fund series. And sixth one is named as Humphrey series. So there are basically total 6 series: Lyman, Balmer, Paschen, Brackett, Fund and Humphrey. The way I am writing, that is considered as the initial spectral line of that spectrum. For example, in this case, in which region it is I need to know. So, what is the region for this? The region is, in the first case, for Lyman series, we consider it is in UV region. It is present in UV region. Balmer series is present in visible region. Now, each and everything that is visible to us, that is because of it is present in visible region. For example, you can see this board, you can see me, all the things. You can see any color of substance, that is because of Balmer series or visible region. Next comes infrared region, also named as IR region. Bracket series is also infrared region. Fund and Humphrey, it is far infrared, far IR region. Both are considered as far IR region. Now in this case, I want to find out the highest wavelength and the smallest wavelength. Why it is so, I'll explain after some time. First I am taking N1 and N2 values. N1 considered as the first line of the spectrum, N2 considered as the second line or the final line of the spectrum. So in this case, in Lyman series, N1 value is 1, Balmer series N1 is 2, Paschen series it is 3, Bracket series it is 4, Fund series it is 5, and Humphrey series it is 6. Now N2 values, what are the possibility of N2 values? N2 values are generally 2, 3, 4, anything is possible. This is 3, 4, 5, anything is possible. 4, 5, 6, in this case 5, 6, 7, it is possibility 6, 7, 8, in this case 7, 8, 9. So these are the possible lines of this spectrum. Now this line will be longest line or shortest line. That will be decided. Let us consider I want to take longest wavelength. I want to take longest line or longest wavelength, or I can say longest lambda in short. For longest lambda, the criteria is N1 and N2. In this case, N2 need to be N1 plus 1. That is for longest lambda we use. Now, let us consider I want to take shortest wavelength. So in this case, N1 value and N2 value, what it should be. Here if I want the longest wavelength, it need to be 2, 3, 4, 5 and 6 and 7. So basically we need to take N1 and N1 plus 1. Now if you are taking shortest wavelength, this is the idea for shortest. If you are taking shortest wavelength, then what is going to happen? N1 value is not going to change. 1, 2, 3, 4, 5, 6. But in all the cases, your N2 value is going to be infinity. So your N2 value in this case is going to be infinity whenever you are calculating this. But why it is so? Why this is longest wavelength? Why this is shortest wavelength? Let us understand. Actually, the idea of this was explained by a scientist named as Ridge. Now let's see. I'm explaining now Ridge formula for spectral lines. What is Ridge formula? We need to check. Now see, Ridge formula we are using. For calculating wave numbers, for calculating wave number represented as B bar for spectral lines, we can calculate it like 1 by lambda or V bar equal to R into 1 by N1 square minus 1 by N2 square. This is the idea to calculate. Now let us consider if you are using this, there is no involvement of Z. Now when this concept was being modified by Rydberg, he has given one constant known as Rydberg's constant, represented as RH. He has implemented the term Z in the same equation. So it becomes 1 by lambda or V bar, that is equal to RZ square into 1 by N1 square minus 1 by N2 square. This is modified form of Rich formula, also known as Rydberg's formula for spectral line, and the constant value we are using considered as Rydberg's constant. What is the value of RH? RH comes 109677, this much centimeter inverse. In some books it is written as 673 as well. So you can use any of them, no issue with it, no much mathematical error comes with this. But actually I prefer to use 1 by RH equal to 912 angstrom. It will help you to solve mathematical questions faster. You can use this. So now whenever we are calculating for hydrogen spectrum, the format is going to be like this. In this, why I have told that N1 equal to 1, N2 equal to 2 for Lyman series is going to be the longest wavelength. Why it is going to be the shortest wavelength when N1 equal to 1 and N2 equal to infinity? Why it is so? Let us see why it is so. For example, I consider I am going to calculate lambda for which series? For Lyman series I am going to calculate. So if I am going to calculate for Lyman series, what is going to happen in this case? I am taking N1 equal to 1 and N2 equal to N1 plus 1, that value is 2. So according to that, 1 by lambda value is going to be, for hydrogen I am taking only, R is common in both the case, largest or shortest. So in both the cases I am not taking the value. 1 by N1 square minus 1 by N2 square. So 1 minus 1 by 4, that is 3 by 4. As a result, lambda comes 4 by 3. That value is 1.33. Now let us consider we are calculating for shortest wavelength. Shortest wavelength has a name that is also named as limiting line. This is the concept I have given for limiting or shortest line. Why it is shortest line? See, in this case 1 by lambda equal to 1 by 1 square minus 1 by infinity square, that comes 1. So lambda will also come 1. See, whenever you are solving mathematical equation, in this case whenever you are taking longest wavelength, the value is coming 1.33, where lambda here it is coming 1. We know that 1.33 is greater than 1 always. So we are very clear, if you are taking N1 equal to the initial value of the line, Lyman Bummer, according to that N1 will change. And the second line, if you are taking the nearest line, means N1 plus 1, then only you are going to get the largest wavelength of the system. So you can say the first line of any spectral series is the largest wavelength and it is having lowest energy, correct? Now see, there are some mathematical derivations, some mathematical formulas to calculate according to Rydberg's form. Let's see that. So in this case, you can see that the basic formula to solve all the questions is this. That is 1 by lambda or B bar equal to RZ square into 1 by N1 square minus 1 by N2 square. And first line we consider as the having highest wavelength and least energy. Among them you need to know one thing. In Lyman series, if I am talking about Lyman has both emission plus adsorption. It is the only spectral line which has both the spectrum, emission spectrum as well as adsorption spectrum. We consider these EM waves are transverse in nature and they are explained by the property of light that is known as polarization. So two more logic. These electromagnetic waves, they are transverse in nature. Sometimes MCQ asked, transverse in nature. And another logic we follow, it is explained by the property of light, that is polarization. Explained by polarization of light. Also, first line lambda highest, frequency lowest or energy lowest. That is the basic idea for solving questions from Lyman series. Now, we are solving some mathematical questions from this. Which variety can be asked from here? Let's check and solve the questions. For example, any random question they can give you. They can ask you, tell me which is the smallest line or which is the shortest line in Lyman series. So in shortest line, if I need in Lyman series, what should be the value? Formula is 1 by lambda. That value is equal to r into z square into 1 by n1 square minus 1 by n2 square. That I need to calculate. So my question is, find shortest lambda Lyman series. How to calculate this? When I am going to calculate this, in this case, I can say the value for hydrogen I have asked. So there is no change in Z value. Z is 1 only. So in this case, Z value is 1. I am going to use N1 and N2 value as Lyman series. So N1 value is 1. And in this case, the N2 value, what is going to be the N2 value? In this case, N2 value is going to be shortest it is asked. So it is infinity. As a result, I can say 1 by lambda equal to r into 1 square into 1 by 1 square minus 1 by infinity square. That is basically r. So lambda is going to be 1 by r or 1 by lambda equal to r. I told you before that I am going to take 1 by r value as 912 angstrom. So this is basically 912 angstrom. Directly we can solve this question. Understood? Let's see the another format for this. Another type of question they can ask you, that is, find out the ratio of wavelengths. I can take the ratio of wavelengths. See, they can ask you what is lambda Paschen limiting line is to lambda, let us consider I am taking Balmer. In case of Balmer, they are asking you which is the largest or highest line or largest wavelength they are asking. Limiting line and highest line, or limiting line or largest line they are asking. So basically use the formula 1 by lambda p stands for Paschen. They asking me the limiting line. So limiting I am signifying by L. Value is r into z square into 1 by n1 square. Paschen series. Lyman, Balmer, Paschen. So value is 3. So 1 by 3 square minus limiting line 1 by infinity square divided by, I am going to take lambda Balmer, highest line I am going to take. So this is 1 by lambda Balmer. I need to take highest line. So it is going to be r into z square into 1 by n1 square. Balmer series, Lyman Balmer, it is the second spectral line series. So 1 by 2 square minus 1 by 3 square. That will be the format to calculate. So from here I can say rz square will be cancelled. As a result, the value is coming 1 by 9, that is divided by 1 by 4 minus 1 by 9, 9 minus 4 by 9 into 4, 36, means 5 by 36 you are getting. So your value is coming 5 by 36. I can write that 1 by 9 into 36 by 5, that is 4 by 5. So basically the value I am getting is 4 by 5. So I can write 1 by lambda p. So I can write 1 by lambda p limiting into lambda b h divided by 1, that is equal to 4 by 5. Correct? So lambda b is to lambda p, that is 4 is to 5. So according to this, if they ask me p is to b, here p is to b is asked. So p is to b value will be 5 is to 4. So by that you can calculate all the formats they are asking. This is two variety of question. There are some more variety of question that is solved by trial and error method. You can see that as well. I am showing you the format. third type of format for some mathematical questions. Third format is, for example, they have told you, let us consider I am taking one wavelength of helium. For helium I am taking certain highest and lowest spectral lines. In this case given N1 value equal to 2 and N2 value is equal to 3. It is equal to which wavelength of hydrogen line? So first what you have to do, this is if lambda is same, find N1, N2 for hydrogen spectrum. This is your question. How to solve this type of questions? See, the format is, they are telling that 1 by lambda helium is equal to 1 by lambda hydrogen. This is our third question. 1 by lambda helium equal to 1 by lambda hydrogen. So the format is R into Z square. What is Z value for helium? Helium atomic number is 2. So R Z square into 1 by 2 square minus 1 by 3 square. This is equal to R into 1 square into 1 by N1 square minus 1 by N2 square. R cancelled. So this is 9 into 4, 36. This is 5 by 36. So I can write 4 into 5 by 36. That is 5 by 9. That value is 5 by 9. So 5 by 9 is equal to 1 by N1 square minus 1 by N2 square. So I have to take such a value that will match with N1 and N2 and give you the result as 5 by 9. By that N1 and N2, whatever answer is given to you, use the data and find out the formulas. By that you can find out for hydrogen spectrum. Another more format is there. One more format I am taking. For example, it is told that for hydrogen, electron jumps from second to third orbit. It is jumping from second to third orbit. The wavelength lambda you got as lambda 1. Find lambda 2 in terms of lambda if jump is from fourth to fifth orbit. This is another variety of question they can ask you. How to solve this variety of questions? See, they are asking you that one lambda they have given, another in terms of lambda they need the answer. So, see the format. Hydrogen electron jumps from second to third orbit and wavelength is lambda 1. So, for hydrogen we know that 1 by lambda 1 equal to R into 1 square, RZ square into 1 by N1 square minus 2 square minus 1 by 3 square. This is the format. 1 by 4 minus 1 by 9. That is 5 by 36. 5R by 36 is your value. So 1 by lambda 1 equal to 5R by 36. This is the format. Now what I need? I need lambda 2 in this term from 4th to 5th orbit. For whom you need? Hydrogen. Same atom you are searching of. So 4th to 5th orbit is the jump. So in that case the format is going to be 1 by lambda 2 equal to R into Z square 1 by 4 square minus 1 by 5 square. So 4 square minus 5 square, that is 16 and 25. Take the LCM for that. So 25 minus 16, we can find out 9. So 9 divided by 16 into 25. So from here I can get some value of R. It implies R is equal to 36 divided by 36. R is 36. So 1 by lambda 1, that is 5R by 36. So R value we are calculating 36 divided by 5. Now lambda 1 is present in above, so 5 into lambda 1 is my format, correct? So I can write 36 equal to 5R lambda 1. So 5r lambda 1 equal to 36, or I can say from here that r lambda 1 36 by 5, or lambda 1 is equal to 36 by 5r. This is my format. Now whatever data I am getting over here, that is my lambda 1 value, I can directly write, or if I want to calculate r from here, I can calculate r, that is 5 by lambda 1 r value. I'll apply r value over here. So 1 by lambda 2, you calculate r value from here. This is equal to 25 minus 9. 25 minus 16, that is 9 divided by 16 into 25. 9r by this value, that is 1 by lambda 2. So for you, lambda 2 value is equal to 16 into 25 divided by 9r, that is 16 into 25 divided by 9 into r value, 36 by 5 lambda 1. So by this, if you equate it, you will find out lambda 2 in terms of lambda 1. This variety of question can also be asked. There is some more terms. For example, first variety of questions. Any electron jumps from n1 to 1, or nth orbital, nth to first one. What will happen? The number of spectral lines, in this case, number of spectral line is equal to, this is nth orbit, n into n minus 1 by 2. By this we can calculate number of spectral line. For example, electron jumps from 7th orbit to first orbit. So total number of spectral line, 7 into 7 minus 1 by 2, 7 into 6 by 2, 7 into 6, so this is 7 into 3, total 21 spectral lines can be observed. Let us consider second case I am taking. It is jumping from n2 to n1. What will happen? The number of spectral line is represented as number of spectral line, we can say it is n2 minus n1 into n2 minus n1 plus 1. This into this divided by 2. So in this case, n2 minus n1, it is jumping from 7th to 2nd, let us consider I am taking. So 7 minus 2 into 7 minus 2 plus 1 divided by 2. So how can I calculate 7 minus 2, that is 5 into 7 minus 2, 5 plus 1, 6 by 2 is 3, 5 into 3, total 15 spectral lines I can find out over here. This is the way how can you calculate if electron jumping from nth orbit to first orbit, and in this case if you are calculating from n2 to n1. One more variety, that is specifically for advance. So the line we consider as, there are 4 type of hydrogen spectrums are divided in separate type of lines. Hydrogen lines have first hydrogen line, second line, third line, fourth line, like that. First line of hydrogen spectrum named as H alpha. Second line is named as H beta. Third line is named as H gamma. And fourth line is named as H delta. So when I am taking H alpha, in that case, we consider n equal to 3 to jump is equal to n equal to 2. This line is named as red line. Sometimes they tell you when electron jumps, we find a red line. You need to understand red line mane they are talking about n equal to 3. As color is observed, then it need to be come to 2. Otherwise color is not observed. Correct? If you are taking H beta, n equal to 4, it jumps from n equal to 4 to n equal to 2. So this is known as blue line. Next is n equal to 5. n equal to 5 to n equal to 2. This line is named as indigo line. Next is H delta. So jumping from n equal to 6 to n equal to 2. This line is named as violet line. How to remember this? Just remember RBI. You know na RBI, Reserve Bank of India, like that we consider RBI, red, blue, indigo. If you remember this three, this is easy to remember. So H alpha, H beta, H gamma, H delta, these are the four lines in case of hydrogen spectrum. Now let us consider if we take some extension for this concept. They are telling that electron jumps from 7th to Balmer series. How many spectral lines can be observed? 7 to 1st, let us consider. 7 to 1st. How many lines can be observed only in Balmer series? That is the question. Means how many are going to reach to the second only, not reaching to first, if the question is asked like that. 7 to 1st you can directly calculate. If they tell you that it is jumping from 7 to 1st, but no line is being observed, no line is going to Balmer series, no line is going to 2, then how to calculate number of spectral lines? See, first possibility, it is going from 7 to 6, 7 to 5, 7 to 4, 7 to 3, 7 to 1. 2 I have not considered. Next, starting point is 7. Next, starting point is 6. 6 to 5, 6 to 4, 6 to 3, 6 to 1. Next possibility, 6 I have taken, so it will start with 5. 5 to 4, then it is coming from 5 I have taken, 5 to 3, 5 to 1. Another possibility from 4, so it is coming from 4 to 3, then 4 to 1, only this is the possibility. If you are taking 3, so 3 to 1. If you are taking 2, 2 is not there obviously. So how many possibilities are there counted? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So how many of the line will not go to the Balmer series? There are 14 lines. If total spectral line is asked, there is 21 line. But if they are telling no line is going to Balmer series, in that case, the number of line will be 14. So what we have read? We have read how hydrogen spectrum is created. First a blue color light is produced, then discontinuous spectrum we are getting. What is the nature of the lights? What are the nature of different line? Which is highest wavelength? Which is the limiting line? Why highest and limiting line you are getting? Next thing we have understood that what are the variety of questions we are solving over here? H alpha, H gamma, H beta, H delta format, electron jumping from nth orbit to first orbit, n2 to n1. So this is all about your hydrogen spectrum till advanced standard. There are some more questions you can do for practice. If you need some more questions, just tell me that, then I'll take few more questions and help you. So I hope everyone understood the topics. Any doubts, you are welcome in the comment section. Like, share and subscribe. Thank you everyone.